Hello and welcome to the second video. This is going to help you with assignment 7, the first assignment on chapter on coordinate geometry. So a bit of change of direction from what we've been doing so far, predominantly algebra. First, the three basic techniques which you need to be able to master really are, let's get the highlighter, there we go. Are finding the distance between 2 points, the gradient, and the midpoint of a line between 2 points. Fortunately, these are quite simple. You just need to remember how to use the formulas. First of all, we'll do the distance. So we've got the 2 points here, 2, 4, and minus 1, 3. Okay. First of all, we're going to find the distance. Now, the distance between any 2 points. Distance of a line between any 2 points can be found using Pythagoras' theorem. Remember, for Pythagoras' theorem for a right-angled triangle, let's get a right-angled triangle up there, is the old classic. You will never ever forget this. A squared plus b squared, there he is, the right angle there, just in case you're in any doubt. And of course the classic formula is a squared plus b squared is equal to c squared. Okay. Now I'm going to work out the distance from first principles, and eventually you'll be able to just apply this into the formula. But if I did a quick sketch of these 2 points, I'm not going to bother drawing a coordinate grid. 2, 4 is going to be in the first quadrat, so let's just put 2, 4 there. Let's imagine 2, 4 is going to be there, and minus 1, 3 is going to be in the fourth quadrant, but to make it look like a triangle, I'm going to exaggerate it and put them minus 1, 3 there. Okay, now what we're trying to find out, let's see if we can do this, straight line, is this distance here, the distance of that line. Now, if they're vertical and horizontal, then easy to find, but here we've got to be a bit careful because it is a diagonal line, and to work out these, we form a right-angled triangle. Okay, so form the right-angled triangle, and now we can work out the distance now using Pythagoras' theorem. So first of all, we're going to work out this horizontal distance. Okay, now this is the difference between the x coordinates. So it's a difference between minus 1 and 2. Okay, now if I was doing this without having to draw the diagram, I would say, okay, to make it easy for myself, I'm going to make it 2. The difference is going to be 2, the x coordinate of that point, take away the x coordinate of this point, which is minus 1. So be careful there. Double minuses. Don't want any negative number cursors. I'm going to put that in a different number. So 2 take away minus 1 is going to be 3. So the distance in that horizontal line is 3. Move back. Let's work out the distance of the vertical line. Now this is the change between the y coordinates. Okay, so now this is where I keep the order. It's really important to keep the order the same, and this is why I sometimes draw these triangles, just to make sure that I don't make a mistake. For this x here, I did 2 take away minus 1. I did this point take away the x coordinate of this point. I have to keep the same order, otherwise I'll get the sign wrong, and that is a big deal. Not so much for the distance, but certainly for the gradient. But anyway, 4 take away 3. It's a good habit to get into. It's going to be equal to 1. Okay. Oh, I didn't make that red. Let's make it red, because we can. Okay, cool. Right. So this is comparing this to Pythagoras' theorem here. We've got our a squared, so which is 3. So 3 squared plus b is going to be 1 squared. That's a tricky one, that. 1 squared. 1 times 1. It's 2. Classic mistake which people make. but it isn't. It is just 1 equal to c squared. Okay, now this isn't rocket science. This is square root. This is 10. Really gave you the rest of it there. C squared. That is the weirdest 2 ever. Anyway, so the distance c is going to be equal to square root of 10. And we could simplify that if it was an easy number, because actually you can't simplify that using surd manipulation. But because we haven't got a calculator, we'd leave our answer like that and highlight it. There we go. So we worked out the distance just using Pythagoras' theorem. You could have done it. You could have done it straight into the formula. Now the formula which they give, or which they give in the textbook, is the distance is given by fiddly. The difference between the x coordinates, so that's x1 minus x2 all squared, plus the difference between the y coordinates. Now, if you ask me, this is an example of a formula making it look nastier than what it actually is. So I think if you just draw it as a triangle, it's a lot easier. It's a lot more intuitive. So that's what the distance is. And that, if we use that formula, we'd get exactly the same answer. X1, we'd have to define a point. Let's make this x1 and y1. And that's what we've done here. And this one would be -1 would be y1 and x1. Sorry, made a mistake there. Make that to an x. And 3 would be y2. Made 2 mistakes there. Telepractice doing this. Okay, so we've got the distance. The distance is the hardest one of these 3 techniques in terms of it's the most to do. The gradient now. Now the gradient is a measure of a line's steepness. Now let's just recap a few things there. Let's get some lines. There we go. Change your colour because I can. Right. Horizontal line. Whoa, that is no line. There we go. Hopefully this is going to be blue. No, didn't want it to be blue. The horizontal line, gradient of 0. Okay, and I'm usually going to call that as the gradient of 0. We can have a vertical line, and that is going to have a gradient of, well, actually technically the gradient is undefined, but you can, hope nobody mathematical is watching this, but it's, we can think of it as an infinite gradient or an undefined gradient. And of course we have to distinguish between lines which go uphill. This is going to have a positive gradient, and we also have lines going downhill, and this is from left to right, that is, depends on your sense, and this is negative. Okay, now the gradient has, I'll call it m, that's the notation we use, is defined as the change in y, so that triangle is just shorthand for change in y divided by change in x. And this would be y2, doesn't matter, if we define our points like we did for the Pythagoras, y2 minus y1, the difference between the y coordinates over the difference between the x coordinates, x2 take away x1. Okay, cool. So let's go back up so we can get that. y2 take away y1 is 3 take away 4. This is where the order really matters, because there is a difference between the gradient of -2 and +2. So there's 3 take away 4. Now we want x2 take away x1, which is -1 take away 2. Okay, now we can simplify that, and so 3 take away 4 is -1, minus 2 take away 3 is minus 3, and of course this just simplifies to minus 1 divided by minus 3 simplifies to a third, because two negatives divided by each other make a positive. And there's our answer for our gradient. Okay, so we've done the two hardest things really. The last thing is to find the midpoint. Now the midpoint is, again, they give you a fiddly little formula, and then actually it's blinking easy. Okay, the coordinates of the midpoint is given by, let's get the coordinates there. So it's x1 plus x2 divided by 2, and it's y1 plus y2 also divided by 2. Okay, so they're the coordinates of the midpoint. So we just need to whack the old numbers in, or substitute, again, for anybody who's actually knows what they're talking about if they're listening. So x1 at x2 is 2 plus minus 1, so that's just 2 minus 1. Divided by 2. And y1 plus y2 over 2, whoa, y1 is 4 plus 3 divided by 2. And I think you can see where this is going. Okay, now that means the coordinates are quite easy here. 2 take away 1 over 2 is 1 over 2, so I'll leave it as fractions. So that's a half. That is the weirdest fraction ever. That's meant to be a half, everyone. 4 plus 3 is 7. 7 over 2 is, well, I'm just going to leave it as 3 and a half. Sorry, I apologise for those fractions. You know what I mean. And there we have it. Okay, now these are easy marks. If in section A they ask you to do any of this, these should be pure bread and butter. It's unlikely they'll ask you to do all three of them at the same time, but whatever they are, they should all be easy marks. So just to recap, distance, use Pythagoras. Gradient is change in y over change in x. The midpoint is literally, technically it's the average of the x coordinates, the average of the y coordinates. You just find the middle one in between. I don't think that's anything too sinister there. Okay, so that's covers the first part of the assignment. Just like to have your attention to this picture. I found this picture the other night. I've been good moves to bust out on the dance floor. The x squared dance move is just moving your hands in a parabola there. X squared plus y squared, it's got it in a circle. We'll come across that little bad boy in a couple of weeks. The 1 over x, beautiful dance moves. And the sine and the cos, that's the waves. You may have seen me do some of them in the class, expertly, I might add. This is a personal favourite of mine. Try them out, let me know how you get on. But moving swiftly on, the next one is type of question. This is more really section B kind of question. Find the equation of the perpendicular bisector. Try saying that after a couple of pints. Of the line connecting the 2 points 9, 1, 1, 5. Right. Beautiful question. Beautiful question because it's it's a very simple question, but loads of maths to do. So let's just get a little grip on this. So let's just draw our points. So 1, 9 is there. I would draw a little sketch, always. One picture tells 1,000 words. Someone said. I don't know whether that's true or not, but there we go. Certainly isn't this. Certainly helps you. And that's what we're trying to do. So la line. There it is. So there's the line. And what we're trying to do is, I'm going to be clever here, I'm going to try and get that in a different colour, but it's trying to phase me actually. Right, that wants it in red. Whatever. perpendicular bisector. Perpendicular means at right angles. Bisector means split directly in two. So I think I've got that about right. I'm pretty pleased with that. To get that in a different colour. I think if I do this, no. Just wasting your life here, aren't I? Are you fiddling about with this? Let's get it on red. Get it back on there. Cushy. Right, I'm gonna get rid of that. Yeah, there we go. And so this will be at right angles. Okay, so what do we need here? We need the equation. And the equation of any line, let's be straight about this. The equation of any line, we need two things. Okay, so I'm going to type this because the finger's actually hurting a bit from all this. Right, here we go. So for an equation, we need two things. Okay, we need a point and a gradient. That's one way. We could also, to get the equation, we could have 2 points. Okay, so these are our two options. We can either get the equation by figuring out, well, oh, there we go. We can either figure out the equation by working out 1 point and then the gradient of the line, or we can work out the equation by finding 2 points on the line. Now, this is why it's such a tricky question, because we've got 2 points, this line here, but reading the question, it says find the equation of the perpendicular bisector. It's this equation, this line, which we want to find the equation to. So we've either got to find 2 points on this line or 1 point on this line and then find the gradient. Now, I think we're only going to be able to find 1 point on this line. I know we are, and it's going to be the point where it bisects the line between the 2 points. Okay, now it's going to bisect at the midpoint. Okay, so a point on the line, let's get there. There we go. A point on the line can be found by the midpoint of the 2 points. Don't know why I'm reading that out while I'm doing it. You can read. So the midpoint. Now let's go straight into it. If we add up the x-coordinates, 1 and minus 1. So 1 add minus 1 is 1 minus 1 over 2. It's obviously going to be 0. And minus 5 plus 9, so that's 9 minus 5, which is 4 divided by 2. Okay, so that's going to be equal to 0. 9 take away 5 is 4, 4 divided by 2 is 2. You could get fractions on this. Here we've got whole numbers. So this point here, 0, 2. We've got 1 point on the line. Brilliant. Okay. Now, we can either find another point on the line. Now, the trouble is we haven't got any extra information which tells us another point on the line, or we could find the gradient, and that's what we're going to do. We're going to try and find the gradient of this red line. Now, there's a relationship between perpendicular gradients which we're going to use, but before we can work out this gradient, we're going to work out the gradient of the original line between 9, 1, 9 and minus 1, minus 5. I tell you what, I've copied that down wrong, haven't I? I'm going to just change the question. Just realised that. Let's just pretend it was like that. I can't be bothered to start the video again because I do have a life as well. So the gradient, okay, of the line is going to be given by changing y over changing x. Okay, so changing y is going to be, let's do it from here, 9 take away minus 5. Smallest minus sign ever, and then keeping it the same order, so important, 1 take away minus 1. Okay, now 9 take away minus 5 is 14. Because 9 add 5 is 14. 1 take away minus 1 is 2. 14 over 2, so this will be 7. Gradient is 7. Now that means the gradient of the perpendicular line, it's the negative reciprocal. Okay, so the gradient And I think we're at a point now where we can write down the equation of the line. Now the equation of any straight line is in the form y is equal to mx plus c. Okay. Now the gradient of the perpendicular is going to be minus a seventh. So we can rewrite this, y is equal to minus a seventh x plus c. Okay, right, we're nearly there. Now we just need to work out the c. This is the y-intercept where the line crosses the y-axis. Okay, and to do that we're going to use this point which we got from finding the midpoint. Okay, so I'm going to substitute, now x is 0, so I'm going to substitute x for 0 and y for 2, and then that will give me enough information to work out what c is, and this is going to be quite straightforward. Okay, so y is 2, and then we have minus 1/7 of 0, and then leave brackets there, plus c. Now this is just 0, so c is 2. Okay, and that means that our line is going to be y is equal to minus a seventh x plus 2. Okay, now sometimes, because there's a fraction in here, a negative fraction at that, sometimes they like to, the exam board likes to rearrange it so it looks a little bit nicer. So what I'm going to do is I'm going to multiply everything by 7 to get rid of that seventh. So we get 7y, and I'm going to add the x as well. 7y, add x to get rid of that negative, is equal to, well, I've got to multiply that by 7 as well, so that's 14. Okay. In the exam, if they don't ask you which way you prefer it, you can put either way. But there's the two answers. Okay. So hopefully that's helped you in your quest to complete the assignment. I look forward to marking it. Obviously you can't see my facial expression now, so you won't be able to tell whether I said that sincerely or not. But good luck, and if there's any problems, come and speak to me before you put the assignment in. Okay? Thank you.